Do 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 do. Bum bum bada bum. Okay, we are we are live. Good morning, everybody. It's Alex. This is the Handmade Game Dev stream. No affiliation. And if you would like to join me for today's extra special stream, last one before I for a bit probably before I go on my vacation. You are going to need your tea, your drink of choice to tide you over during this very difficult time. And we're going to all go take a sip of it because I kind of woke up a little tired. I'm not gonna lie, and I definitely need this. All right. We were in the middle of doing a bunch of refactoring to help support the Mac version of the game, as well as to kind of just get this generally working a little bit better, or more extended to be able to work on multiple platforms. So that is what we are doing right now. We started off over in here in our actual game code. This is the code formally we were trying to own and make the entry point of our program, and it just kind of does all our memory arena allocation stuff, and it was going in and calling our OS, going into the OS and telling it to go set up a window or screen, whatever it may be, and then going in and then initializing the render API, which in our case was D3D11. And now that we are not, now that we're kind of moving all this stuff around, these things are all going to change. This stuff is all getting kind of shuffled around, moved. So we have that game init. We have this game loop that we want to be looped by the platform entry point, to have that control it, and this is just going to get called basically every frame. We'll go through here, do all of our fun game state updating business, and then at the very end there will be the graphics updating stuff. So we will shoot everything over to the GPU and draw to the screen. Oh boy, wow, that was the fastest I think the ViewBot has come on. Go away, Mr. ViewBot. All right. So we've been fighting with a couple things as we go about here. One is I'm not sure why this macro is not evaluating properly. That is something that when we are compiling a little bit more than this, we can try to figure out, but right now not working. One thing that we should do, I think, is we want to chase a couple of these down to figure out where we're having a ton of compilation errors, right there. So we're gonna get rid of that. So I guess, yeah, basically now that we're done with that game that game part, pretty much everything is super coupled together tightly with Windows right now. So I think the strategy should be, we can kind of statically rewrite some of these things and decouple them, or we could also be just going back to the Mac layer and then running out procedural style the things that we want it to be doing, I guess. I think that might be a good exercise to go, and then as we come up with things that or come up with the spots where we want to bring stuff in, we can go in and do the rewrites just in time there. So let's try that. Gotta drink my matcha, man. That is the most important meal of the day. Alright, so we are back here in macmain.mm, and this boy this bad boy is our new entry point into our program, and it's just using the regular main. Unlike in Windows, where they if you were to use like Win32, they were overwriting the entry point of a typical C program with WinMain, so fun stuff like that to deal with. So, I guess the thing that we want to do is, we were in the middle of copy pasting a bunch of stuff from Ted's code. This is our code, our existence proof here. That you can do this, and you can make your game sort of platform agnostic in this way, or at least platforms supporting a bunch of extra platforms in this manner. So I wanted to go check and see like what kind of stuff he's doing, and he's doing stuff very procedural style of, and to be fair, we were too, but we were doing, again, most things trying to have them live inside inside like our entry point, our custom entry point, as opposed to respecting the OS entry point. And so basically all of these things go around in order, blah blah blah, all the stuff, sound, controllers, all that jazz. But I think the important part, we dug through it. We dug through it a little bit. I think all of like the real looping code is in here in Metal View Delegate. I think this is the actual. I think essentially what the theory is to is basically you set up the metal view delegate as essentially the like handler for the window. You just like you construct it and pass that in, and then inside here has not only your render loop, but also your just entire game loop in this like metal toolkit view. So I also, there's metal toolkit versus metal kit or whatever. There's a couple of like different like weird things here. So we're still kind of trying to parse through all of the Apple-y nonsense that's going on. But you'll see, we just scrolled past a bunch of like input handling stuff, and now we're right here. So that was game loop right there. Input handling, game state update, game render. There you go. And this is like the real spot in Ted's code where things are actually happening. And this is so this is pretty much what we need to make. Once we have like init, or we have kind of init, but we need to make the init work with all of our stuff. But basically, all of this is what we really need to be doing. And here is where there's just going to be a ton of like, we're gonna write to metal. We have to go change our model of doing rendering stuff from all immediate context to like a command buffer. That'll be fun. And then we shoot it over the wire to the GPU, set the stride, all that stuff, and then it will just simply go do the thing. So that's a lot. That's a lot of stuff to do here. And that's I want to just make sure of like where this gets called. Yeah, so I think this is because this is basically the actual thing, right? This is the actual function that's getting called, but this is not in any of Ted's code. Oh, you know what? It's because also we need to remake the buffer. That's so annoying. Oh god, someone's gotta freaking fix that. Someone has to. Alright, I don't want to rat hole too long here, but I want to see. I do want to see what the LSP like thinks is the root. Here we go. What Clang like thinks is the root of that second one. So it does think that that's the root. So it's actually not Clang's fault. It is well, because it can find the root of that other repo, so it should know where to go, right? It should know where to go. But then the problem is, if I go here, yeah, okay, look, so this did find it, but then it's my grep that doesn't work. My grep, yeah, my grep goes to the wrong place. But oh god, this is some real stupid stuff here. Because the grep is not LSP specific. This is just in is this in telescope? My telescope bindings? Yeah, it's in my telescope bindings. And it's you know, maybe I should have. I just need to make another binding that greps from the current file's root. Yeah, that seems like something we would want. Yeah, let's ask our friend here to help us out with that. I want a new binding that greps from current buffer location / current buffer project root protected by LSP. Because, like, oh my god, I have to do this so much that it does drive me freaking crazy. I want to see, like, what kind of junk this comes up with. Alright. Yeah, and so here's and it is annoying, right? Because this is, like, here, I have to... My model of the splitting up telescope from the LSP is a little wrong, but I guess this is where we use the built-in NeoVim LSP stuff, and we do not need to load all of those plugins in here to figure it out. Live grep roots. Yeah, it does kind of look like what we would want it to do. So we want it to be nil, right? We get the client of the current buffer. If there's a config and a client for router, then we do the router. Else do that. Okay. Okay. Yeah, alright. I will take this, and then we can... Oh, what the fuck? Uh, oh, come on. Oh, what the hell was that? That always uses get root. No, that's not what I want. Oh, I guess that is me. Um, because like here's the thing, like that this pisses me off. Um, because I like it is. Basically the thing I'm trying to do is usually I'm always grepping in my current workspace, right? But I do want like I do am looking into other ones sometimes, right? And I want to be able to search relative to that. But they are not always Git repos. Um, so I guess like what is the hierarchy of stuff of things that I would want it to search? I think I would want it to search from if it's a Git repo, we probably want to be searching relative to that Git repo first, right? Um, because that is like there are code bases or repos where it is like you have multiple different code bases in them, um, and maybe the anchor is not quite right, is not quite evaluating correctly, but and that is like that is the I think the typical fallback for the LSP for most LSPs to find the project root is they just find the top level Git anyway. So I think I think that means that basically we don't need to care then, right? If like they're just going to go, I'm sorry we were so sidetracked here, but this is like literally a binding that I'm using every single day. It drives me crazy every single day. It's really annoying. Um, yeah. So, uh, I do think that the LSP root is probably fine then. Which ones are these? It's Mason LSP config. I know there is a page somewhere that has like whatever all these default configs that go in here. But I can never find it. It's very irritating. Is it an LSP0? I think it's an LSP0 that has that. It's in LSP0 or Mason. Is it? Oh, here we go. nvim lsp config. I think this is it. I think this is it. Let's see. Yeah, this looks right. So let's look at like the ones that we're actually using. So clanged, I'm fairly certain this defaults to look for the .git as the root, unless you feed it a more specific one. So that's good. That's what we want. I like if this and I bet most of these must have a fallback to the Git root, because that would be kind of silly if they didn't. Which other ones do I use here? Oh god, I think I need that Docker one. That's irritating. The GLSL one, it's probably good. Go please. Oh, hmm. It's standard looper. Oh, here we go. Yeah, also .git. I'm gonna like go out on a limb here and say that they probably all default to .git. HTML .git. Because that's what they should be doing. if I were designing this and I was literally just trying to, right, I would want them to be defaulting to the .git. Okay, so yeah, I think we can do that without needing this extra thing. Okay, so let's do that. Let's grab this crap. We want to go back to Telescope. We want to, oops, shove it in here. Shove that in there. We'll kind of get rid of all the stupid comments. Okay, leader PG. Yeah, I think that's an okay one. That's an okay mapping for it for now. Okay. Yeah, we will do that. And then, let's see. So we'll go in here, and then we'll do our leader PG. Oh, that didn't work the same. So that's not quite right. That's not the right spot. We want it to be built-in grep string. Yeah, we want it to be grep string as well. We'll just do that. Okie dokie. Okay, we don't really need that. Okay, let's try that. And then we will have this look for like game memory. And look at that! Oh, it works! Oh, it works! Excellent! Excellent! And this should still just be from our thing, which does not do the thing. And this should be the thing we want. Okay, cool, awesome. Let's do that. Okay, thank God. Oh my God, that has irritated me, I think, since I started using NeoVille. So no matter what, today has been a productive programming day for me. Okay, alright, what were we doing? we were trying to port this thing to Mac, or we were writing Lua today. I think we were trying to write to Mac. But excuse me for a minute. I'm just gonna go fill up a cup of tea really quick, and then we will come back and actually get started. Alrighty, today I've got some silver needles white tea. This is the first brew, and the silver needles do take a they do take a couple times to really unfurl properly. That basically is totally clear. That's all right. Well, we've got plenty of time to drink tea today. It's nice little rainy, shitty morning here where I'm at. So we've got, we've got perfect tea sipping weather, in my opinion. Not that there's any weather that's not suited for tea sipping. All right. Yes. So the thing that we are going to need to be doing here is as follows. We are going to want to. We are going to want to have the metal view delegate, right? We need this to be the place where we kind of are pulling in all of our code from everywhere. We are going to need to I think let's see. So we want all of our types to work in this file, all of our primitive types to be available in this compilation unit. Whoops. And they are right now, right? Because types is compiling. Is this a problem? This shouldn't be a looping problem, because this is all of the game stuff should be compiling as C++, and we're trying to. We've removed, I think, everywhere where our C++ code is trying to include anything compiled to Objective-C, right? I think we have gotten rid of that. So all of our compile errors are just from places where it's Win32 or Direct3D API stuff that is just hard-coded in there and not pre-processed out. So that is that's kind of what all of these are. Which is a little irritating. it's a little irritating because we were kind of not able to see super well what things are working right now. Is that oh, that's interesting. This actually gave me 3 different warnings here. I don't know if I've ever seen Clang do that. Can't recall. Crap. We did also want to do the thing where we split these up into a library that we're dynamically loading, right? Um. Uh. 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 Yeah. We probably do want to just get that over with right now. If that's even something like useful at all. Because here's the if all right if we do that, does that actually help us, or is it just like a is it like just kind of something nice if we do like the uh we can kind of like get it to work. So what is like the reason? Let's let
Bonus in a
Casey
lot of
tell us.
cases, because if you can edit the scripting language while the game is running, you can tune variables live on the fly. You don't have to try to, exit, recompile, go back into the game, that sort of thing. And you can also do stuff like, well, if you're trying to debug the behavior of a boss monster, you can just go in there, when you get to the boss monster and see that it's not working, you can just right there pop up the script, start editing it, see what the boss monster does, and change it and all that stuff. And it saves you from having to make a whole bunch of scaffolding to allow you to like exit the game, change some boss monster code, jump back into the game, jump straight to the boss monster, actually deal with the stuff there, look, see how it went, go, oh, okay, it didn't work, jump back out, blah, blah, blah. So there's kind of a lot of stuff there where it's like that ability to just use, to edit the code right in the middle of the game is pretty valuable, actually. That's a pretty big thing. And so there is something you can do there, right? You can, inside Dev Studio, right? If I open up Dev Studio, there's a thing called Edit and Continue, right? Which allows you to edit stuff inside Dev Studio. You can set a breakpoint, you can edit some stuff, and you can have it recompile. And that works for some very limited cases. Like, unfortunately, a lot of the time, edit and continue doesn't really work. Like, if you're writing tons of new functions, and if you're actually trying to really write new code, edit and continue doesn't work. It's usually for small changes is the only thing that it's really reliable for. Otherwise, it mostly just breaks. So edit and continue isn't really a good solution, but it's sort of like what we would want, right? What we'd like to be able to do is just kind of go like, all right, the game's running and we have the C code. We want to just be able to edit the C code and have the game just keep on running, right? So the question is, well, could we basically implement our own version of edit and continue, right? Like, is there some way that we could go ahead and do that where we actually don't have to worry, we basically don't have to care about Visual C++ and whether it can do whatever it's supposed to be doing with its compilation step? Could we actually make it so that we have what amounts to our own sort of relatively foolproof edit and continue? And so what I'm going to do tonight is I'm basically going to try to implement that. I'm going to try to implement a way where we can basically have our game running, change the code live, and not have to restart the game to see the results, and just basically let us kind of go from there. And we'll see how far we can get towards that goal, basically. And I think that's kind of fun, so I said tonight's kind of time to do something fun. Rather than, if we wanted to, we can make it so that we can just reload that code on demand, essentially, right? So if we want to, we can say, okay, this is Win32 load code. We could also do something like this, Win32 unload game code. Is we can go in here and say, now we actually have a problem, I just realized. Basically what we did is we took our build.bat file. We decided to build two things instead of one thing. We split the game code into one basically executable chunk and the platform code into another executable chunk, right? We then have the platform executable chunk load, and whenever it wants to, it will reload the game executable chunk. It then calls Windows to ask it to give it the address of functions in that chunk, in the chunk that it loaded. It says, where's the sound samples function and the update and render function, because that's the two functions that I need to call. It gets those back from Windows, it calls them, and when it calls them, it passes in a struct, in addition to the structs we already defined, like the off-screen buffer and that sort of stuff. In addition to those, we also pass in any functions that we need it to call us back at, right? So any calls that go back to the platform layer, which are only debug calls at the moment, but if we had any that were actually real calls, we could pass those, right?
All right, yeah. I mean, like, because like the whole thing we're really trying to do is be able to like I've already found the use case in for wanting to be able to change stuff in while the game is running a little bit faster. A bunch of like tweaking a bunch of variables, moving stuff around in a level, and a lot of that is just solvable with just kind of having more live editor features in the thing, and just giving like exposing some of those parameters to tweak. But that is a whole bunch of work to do that, and like the question is like, is this, how much work is it going to be to do it this way? Because what would need to happen, right, is that the game library is not the actual owner of the of like the current like world state in memory. I guess because like otherwise, like if you blow up that DLL, like the platform executable calling into it is the thing that should be not cleared, and like just like I don't know. All right, I'm not gonna do that right now because it seems like a whole problem that we really don't need to solve at the moment, and we've kind of got enough on our plate as it is. If we need to, we can move who is owning the real chunk of memory that has our current state in it, and then we can take it from there. Okay. So we do still need after all this rambling and diversions, we have to do this metal delegate stuff. So we need to go and make sure it's in the build here. I think we're gonna need metal kit as well, unfortunately. Oh well. These are all good. Those are all good. And then I think we can go in this one, and we'll start. Oh, whoops. We will start by just doing some copy pasta here, and then we can figure out what are the specific things we're looking for after. Now, interestingly enough, Ted has this as like an Objective C file and not Objective C++. I don't know if that is going to be a problem, if there is something that why? LSP really doesn't like that one. We'll provide some helpers here and then see if we can get that, massage that in working order. There we go. There we go. So let's just start by culling everything we know we're not going to use here, and then we can kind of try to read through and figure out what's going on. All right, so we definitely do not care yet about. Actually, let's make sure we have all the headers we need. That would be a that would be a good thing to just to ensure here. So what? Let's see. I think like he's just, because he's like Unity building it, they're all in that main file. Yeah, so we will grab this one as well. Okay, and then all right, and now let's start calling. So we'll get rid of that. Get rid of that crap. We'll get rid of that. This preprocessor stuff. We won't get rid of that just yet. We don't need this. We don't care about that yet. Don't care about this. We don't care about that. Oh god, that's like a lot of stupid boilerplate. We are going to not do sound yet. We don't need any iOS stuff. We don't need any Steam stuff. Okay, and here we go. And we have the actual handler. I'm going to actually go get rid of all the controller stuff because we simply just do not care yet. That may come to bite us later, but oh well. Let's see. Yeah, you don't have all these stupid key mapping things. Da 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 da. Okay, and then we got to his game loop. Oh, and he's just always locked to 60 FPS. That's interesting. Alright, we will get rid of, again, all of the sound buffer stuff. Simply just don't want that yet. And then, okay, here we go. And then we get into the meat of the rendering pass here. Okay, cool. Yes. And I think, again, a lot of this stuff, we have to check to see how this is getting encoded here. Okay, that's all of that stuff. That's good. Okay, so let's start from I guess like here. So yeah, so when he does game render, that generates a bunch of render commands, and then we have to figure out like what actually is this list of render commands that he's doing. How is that different from like our immediate context mind here? And this is like all kind of the same looking stuff as we've got in Direct 3D. Just kind of like setting a bunch of pointers at stuff. Maybe telling it like how to walk the buffer. Okay, and then we actually go in, and here is like the mapping of the game owned draw buffer to the one that Metal cares about, right? And he is batching all of the commands in per layer, having a bunch of commands, right? Get Apple instance buffer frame and offset. And then where's like how I guess like how is he sampling from a texture, right? Set fragment texture. Yeah, I don't see like the UV, you know? Let's see. Does oh wait, here we go. Set the texture size. And then maybe it's this uniforms thing is what it's actually sending in. So if we go look at his wherever he's got his like vertexes. Oh, what? Oh, that is really irritating. Who, like, what got mad at me there? Okay, so let's look. Yeah, so he's setting like some clear color stuff. Layer index. Instance buffer. Oh, we don't care about this show frame rate thing. Okay, so tile map position. Yeah, because he's got tile map kind of baked into here. There's some sort of blah zooming. This is like his projection matrix, basically. Okay, here we go. Here we go. As you try to get entity. And so, what is he doing? Push textured rectangle. Let's see where that is. Oh, fuck, that is annoying. Tree sitter highlighter. Yeah, this keeps on breaking, which is really pissing me off. Because I think this is one of the stupid things that I did to get the warnings to go away, and then that just made it worse. Highlighter. Oh, interesting. That may not work, right? Let's get rid of that. How about that? Why? Is it because it can't find my... Man. How irritating. Update your parsers. Yeah, somehow I think that's like... Maybe it's not gonna work? Yeah, it's not gonna work. Yeah, somehow I think that's not gonna work. Yeah, I guess we can blow up the cache. Ugh. Oh, I've already blown up the cache recently. I suppose we can uninstall. Not by Envim Tree Sitter. Where's that in here? Alright, so we'll just get rid of that. Okay. It's possible that it's got some garbage cached, I suppose. Yeah, okay, now we're gonna recompile, grab all of these again. No. Whoops. Is it because I don't have the markdown one? Oh man, today is like just like kind of a pain in the ass with the tooling, isn't it? Ugh. Ugh, I say ugh. Yeah, the markdown one, it likes. What is the damage here, man? Did they just like? Did they just push a bad commit to like the markdown? It's very possible. Something not right, quite right here. Something not quite right. And why is it like not like this one? I think it may be from Telescope. Because it is like in here, but it's also because this is like opening this markdown first. And like this markdown is, yeah, oh, it's definitely breaking here. How do I see this this trace? How do I, not that. Oh, it wants me, because it wants me to like tell it markdown. Oh, come on. Oh, here we go. Yeah, so it's like the highlighter for Markdown is broken. it's, it's so stupid. Yeah, it kind of looks like someone broke this thing. Extra things to support Markdown. Um, well, the error is way more annoying, so I'm gonna get rid of it. Huh. I guess someone must have changed this. Oh, well, perhaps this is where it's cached. Hmm. Now that is a little creepy, ain't it? Oh, that's all dry in there. Oh yeah, this is like kind of installed all over the freaking place, isn't it? That's really not good. Lib vim parser. What? Okay. Oh god, and now and now okay, good. Oh, and look, now it's working. Okay, thank God. That was incredibly irritating. Um, but okay, that one could be. Oh, it auto installed that. Uh, oh fucking now it's broken. Yeah, I think they just have some bad freaking They must have just some bad commit in there. That is so annoying. That is so annoying. Unstable. Yeah. Fuck. What happened? Perhaps they require some sort of magic here to get this to not error. Be very annoying. That sucks so much. Man. Because it just does not work. That's not fixed at all. No, it's like there's an actual there's like an actual bug in this markdown now, in this markdown one. Ugh. All right, you know what? We'll just get rid of that change, and then hopefully that is one that someone just fixes. Oh god, just so annoying. Waste so much time with that nonsense. All right. Anyway, we were looking for the actual how he's sampling from these texture. Oh right, and then we were doing that. Okay, so let's find. Is it this texture map crap is the way it works? Color palette. Where are we? Where are we right now? Oh, look at this. So he so he's got this abstracted out a little bit, so it's not just the raw UVs. There's some sort of texture ID that is wrapping that. I'm sure. Text character lookup, texture ID. So if we were to try to find like how these texture IDs are mapped, that would be what we would want. Because like I just need to figure out like where is, you know, what is the primitive, the vertex primitive, and like what kind of crap do you need in there? Does he have in there to get it to work with metal? What is the sauce there? That's pretty much it, right? So this one has position UV, right? I mean, it must be that, but then somewhere texture ID alpha. Okay, so this is what a texture draw command is. I don't know what vmin and vmax are, right? That's a question. Some of this stuff. The array is, yeah, a bunch of those. Okay. You know, he sorts them. Okay. And then, all right, yeah. So this is all in like the game. So then I think, you know, we should be able to find somewhere how metal is understanding that vertex. Oh, set up alpha blend. It doesn't look like. But here, set up metal texture. this looks pretty promising, right? So it should be like some magic Objective-C looking thing like that. That kind of looks like what we're going for there. Yeah, because this is the MTL texture. Yeah. Okay. All right, and then we got shaders. Right, we'll figure out the shaders in a second. But where? Okay, here's like just binding the shaders to the pipeline. Oh, here we go. Oh, here we go. Here we go. Alright, he's copying some stuff around. That's fine. Grabbing the buffer. Okay, blit encoder. Copy from buffer to buffer. Size, buffer length. Yeah, okay. What is a uniforms buffer? I'm not familiar with this. What is a uniforms buffer? Metal rendering. So what is this? Holds constant. Oh, this is the C buffer. Okay. Oh, things that your shaders need for every draw call in the frame. Interesting. Okay. You put your uniform struct into buffer, tell it where to find it. Okay. Oh, and so you don't need to. Is the whole thing just encoded in the shader? Is that it? Position UV? Yeah, this sure looks like that sure looks like what we've been looking at. Okay, alrighty. And this is like a lot more. Oh, he's just doing. Yeah, well, so we should be. The vertex shader should be controlling the position of the things and stuff. But what is the. Why is this so big, right, is the question. What is all going on here? Okay, so he has to convert to pixel space and just does that on the GPU. That's fine, that makes sense. And then he's doing rotation on here and position. I'll put the normalized device coordinate. Sure. Okay, so it's not actually that complicated. It is all the stuff. It is all the stuff, but he's having the math really get done on here, as opposed to, in our code, like really was doing a lot more. We're not handling rotation, obviously. But we're doing a lot more on work on the CPU, I think, by generating the transform matrices. Because we're consuming the transform matrix when in the graphics layer here, right? To actually go construct a like a draw right here, right? This is all happening CPU side to actually modify all the vertexes. And so then their basic, that's why our vertex shader basically is just a pass through, right? It's not doing anything. And then the pixel shader is just doing this, just sampling. That is most curious indeed. Because like it does sound like that is work that the GPU should be doing, right? So why would you not? Why, like, why, Also, is there like a TS install, like metal shader lang? I know we just saw the HLSL one. There is no metal shader lang. So sad. So sad indeed. Maybe the HLSL one will work. Probably not. I'm too stupid to know. I don't know what is a fragment shader. Oh, it is just the pixel shader. Why is it called a fragment shader? Potential pixel. Okay, I see. Got it. There's another conundrum for you there. Yeah, cause like that stuff really should be owned by the GPU, I think. But is that ever a problem? Because basically every render API is going to, in the world, is going to want me to provide my it's going to want the vertex shader to do this work, right? Unless I'm just totally missing something. I think not, right? I think it's just an incorrect assumption, unless it's like really, this is something you just want total control of, right? Need CPU access to transform. Oh, uh, yeah, that is a that would be why, right? Because we do we 100% the vertexes to already be transformed for our collision detection, right? Like if we just look, like this is, and like we're doing all that math on the CPU already, because we have to we have to find where all the points of these collision boxes are here, right? And I think, if we are to, let's just install move solutions to B. Actually, I think I have it built locally. I think I've got it built. Let me see if I. Let's see about that. Okay, here we go. Yeah. Okay, and there's something screwed up here. We actually just saw why. Is that Ted has it hard coded to always be, things were supposed to be running at 60 frames, but my monitor has like a 180 hertz display. So this is like not quite right. But I think this is a problem on like the real shipped version of the game too. But oh well. This game has no physics. You know, everything is the only amount of stuff. You know, if you look at all these quads in the game logic, this is a Sokoban game, right? So the game like state logic is that is just a tile grid of like which things have an entity or what entities are on which space or not, right? So that is totally not a oh, also okay, there we go. He has no need at all to access real vertex transformation data during any of like the game update step. Yeah. Because like because right now, you know, in my game, like basically, you know, we're overloading the use of all our quad vertexes for rendering and for game state. But I think like that just wants to be the same thing, right? Because like the work has to be done on CPU to know where all the stuff is, no matter what. Especially if it's like a game that can kind of be, you know, whatever going on. I actually am kind of curious to see if he shipped with this bug, because that would be nice to go tell him. What? Why can't I click this? Oh. So annoying. Did he ship with this bug? I would... Okay, no he didn't. Okay, so there's just something weird in the, there's like some build flag I was missing, I guess. But anyway, go play Moose Solutions. This game's awesome. Oh, that looks like a bug. Yeah, I don't think that guy's supposed to be there. Anyway. Okay. Yeah, because we like kind of need that. Yeah, we kind of need that. we like think perhaps this could be a problem. We kind of need that because like the physics should be owned by us fully and deterministic. Yeah, that we want. Yeah, is almost always better. Yeah, and that's the thing. Like, that's where you would want it to be. Shader skinning. I do a lot of real time. Yeah, that stinks. Yeah, like, cause we really don't want to do that. That would be horrendous. Cause then you're forcing yourself to have to take on double the the cost every frame of sending shit over the wire, which is so bad. It is so bad. But then, like, man, how does anybody get away with this if they have like any re like r- like collision stuff in their game? I don't understand. Like how like if I was the Legend of Zelda Ocarina of Time, you know, like that game doesn't need to have it doesn't have like uh it has collision detection that it must be doing, right? And it's not just like a tile based game where you can kind of fake it out. um if I am the Legend of Zelda and I don't have like an incredible physics system, I'm not like the new Legend of Zelda. Like how would I do that? Like what kind of state would the CPU still need to own to or what like is the minimum level of state the CPU needs to own to so that you can just pass all over that stuff, right? And it would be that the colliders can be CPU owned, right? The colliders and some kind of like overall world position would be, but then I think the model, um, the 3D model on top of that, you would send over to your vertex shader, right? Of like yeah, like your mesh and like the current animation state. You could pass that pretty, I think, to the GPU, right? And then you do like all your bone transforms on there because they don't actually affect game logic at all, right? But game logic says that I should be at this interpolated part of the animation, and then you do all your transforms with that. I think I think if I'm thinking from first principles, that is the use case for doing that. I think that's what you would want. And right now, again, because all I'm doing uh is just textured quads with no and like all of my animation is going to be done likely in uh sprite sheet like flickering between frames style for like quite a long time. Like I think it's still something that I don't need to care about yet. Um, I think that's something that I can defer for a very long time, especially while just like trying to get like a MVP of the game, right? Uh, I think I think that's it. I'm glad I walked through that because like like I was this close to also rewriting all of this shit to be done on the GPU. And I'm so glad I just talked myself out of that. Because that if there's one thing I don't need to add on to the list of crap to do, it's that. Okay, well that makes sense. That all makes sense. I'm pretty square with that. Um, I'm pretty square with that. But like, yeah, obviously the pixel shader stuff, that all still needs to do the things it does. Um, when using Metal 3, my game has its own vertex buffer. I'm trying to pass to the render API. How do I tell metal the layout and stride of my V buffer? And I think the answer is literally that it's just encoded in the shader directly, and it's just byte reading it. I hope is the answer. Okay. Well, yeah, that's what we have. Oh, metal vertex descriptor. Okay. Okay, we can look for that. Metal vertex descriptor. That does sound like what it would be, and it's not in his code. Oh, because we spelled it wrong. And it's not in his code. When creating your render pipeline state. There's the color attachment, right? We were looking at that earlier. Pixel art pipeline descriptor vertex function. This is where all the binding is happening. Pixel format. Oh, that seems reasonable, right? Color pixel format. But that's just the color channels, right? Yeah, and that's like, yeah, this is like what we were looking at before, right? And so, yeah, I think maybe he's just not doing it, and then relying totally on the shader to have that information encoded. But if we were to look at like the Windows version of this that he's got, like this, I'm fairly certain you need to tell it. Also, I'm not really sure what this is. That doesn't look like any shader I've ever written. Oh wait, here we go. This is the shader. Yeah, so he's doing all that jazz. Vertex buffer. Yes, that is the instance buffer. Oh, that's what we were just looking at. So where in the world does this guy set the vertex layout for this thing? I don't know. Like, is that something you just don't have to do? Am I stupid? I'm likely stupid here. Like, is it something you really just do not need to care about? Oh yeah, because this is like disassembled, right? So this is yeah. So this is like not even. And I think that maybe like that's how this is accomplished, right? Is like perhaps the way I am doing it. Oh, that's interesting. So I guess that's an optimization there that you could do to make your shaders a little bit more efficient. They have to use less GPU memory, which is maybe limited. Or for GPU I memory. But I am so curious, like how how on earth does this know? Does he have it like in his setup here? Because that would be, yeah, like I thought you needed, because I've had like now a whole bunch of bugs literally just from that, right? Of like my vertex layout changed in one spot and I didn't change it correctly in another spot. Uh, and if that's something that I just like am doing wrong, if I'm like I don't like understand how shaders work, I guess. Uh, oh no, that's his like game logic owned one. Oh no, here we go. Here it is. Okay, so yeah, you do need it in Direct 3D. But I guess you do not in Metal. Set vertex buffer attribute stride. Hmm. Yeah, so maybe they do have some weird hack around it. Yeah, I figured, right? Because like you know, I would think that like, because this is like your contract with the GPU, that the memory you're passing in like is sensical, right? So I feel like that's something that the render API should have. I'm just like, I was just a little confused here because my buddy Ted's code is not using that for doing the metal stuff. Which is a little odd. I didn't think that like a render API would let you get away with such a thing. Would let you get away with just um, like passing in that data and then interpreting it on the other end. Because it does seem like something like you maybe would prefer to have that compile error of like Direct 3D not liking that you changed a layout, your vertex layout before you actually get to your thing, and or you like run your game and your vertex layout changed, causing you to have like some horrible artifacting, right? Because then you're like, oh god, what did I do, right? Um, yeah, that's just that's weird. But I suppose like now we know now now we know what's going on. Oh, maybe render past descriptor. That's not quite. Uh, all right. Well, that's something. I'm glad we've solved that mystery. That gets us one step closer to actually being able to really implement the metal stuff kind of correctly here. Um, Yeah, well, thanks for the thanks for dropping by, Ernev. As always, we've got another 15 minutes of the stream here, and unfortunately, it doesn't look like we're gonna solve world hunger in the next 15 minutes. But I'm glad this has been a lot of demystifying creepy stuff, creepy Apple stuff today, which I think is good. I think that is overall what we want. Like, kind of now know what is going on here, and with all this uniforms and stuff. So I think, yeah, because I think the thing we're gonna end up with likely is, you know, we are. Oh, I had it. We're probably going to pop over like the same shader from Direct 3D, where we are just doing vBuffer IO really stupidly. We're gonna keep most of that. Our vertex transforming on the CPU because we need it for physics. Just fine. At some point in the very distant future, I'll likely have to rewrite that I may have to rewrite that to SIMD it and to squeeze performance out, but not anywhere close to right now. Which would be fun though. I've never actually done written SIMD stuff, so that'll be cool. And then the pixel shader also is like, yeah, this must be like exactly the freaking same, because it's like purely just an IO thing here. In our Direct 3D pixel shader, it did have like some extra garbage in it that I kind of wanted to take out almost, but there's this thing so that we can have draw circle primitives, which I might take out because like I don't know. I'm not sure we're gonna need the circle primitive, but we might. So oh well. It does like inflate our vertex size a bit for not really a good reason, but this is the one that actually matters, is the Atlas ID, because that does change. Well, no, I suppose all of the pixels still are 4-channel. No, actually that should be super portable, right? But because it's the our sprite sheet is actual RGBA, and then the font atlas is like an alpha only image. So we just have to like, but we grab the color from like when we hard coded in. What's up, Gemini GU? What is more important in the job between syntax and logic? I think it's most certainly logic, right? Because syntax is something you will just learn over time. Syntax is like, what's up, Vindren Gauma? But yes, syntax is like you need to know the syntax to actually write stuff. It's very important to have a grasp on, especially whatever language and then like APIs that you are using, like how to like what the words are, so that you can describe the logic you want accurately. But the logic is the thing that actually is going to determine if your program works, if your program is performant, if it suits your needs or your users' needs, right? And it is, it's far more difficult. Your engineering work is spends vastly more of the time in logic than oh, that's good. I'm glad I got it. But yeah, no, logic is way bigger. Also, I did this wrong, right? I think this needs to be import. Oh, oops. I think that needs to be import instead of include for the Objective-C stuff. Not sure if like it cares that much, but we should just try to try to play nice with it, or I'm scared that Objective-C will get angry at us, the Objective-C gods. Yeah. So let's see. We're kind of just killing some time here till 9 when I've got to log off. Have gone through, try to build up a better understanding of originally wrote my game in Windows using all like the Windows and Direct 3D APIs to draw stuff on screen and interact with the operating system, all that stuff. And a lot of it has been very interesting trying to port this to Mac at this point, because it has told me like a whole bunch of places where assumptions that I had about the way that you should be doing things were actually like which of those were actually platform specific, of like they were just from using those specific APIs, and then what things should be a little bit more or less abstracted out or owned in the correct sequence in order to be really friendly to supporting multiple platforms. And so that has been, I think, a super interesting part of this like last couple of week, or I guess last week of work here, um, because this is uh, it's like I think a very powerful skill to understand like what are the considerations that really would need to be made for like your multi-platform native code to really work, as opposed to kind of relying on someone else's super abstraction on top of that. Like if you were to write like an Electron app, say, and your like common platform is like is the web, is the browser, and the browser engineers are the ones who actually control and take like really do all of the stuff underneath, right? Because that is, someone needs to help those guys out, but also like if you don't if you do things in a way that makes more sense for the computer, right? If you're or for the operating system, if you're actually using the native API instead of like going through a whole bunch of extra layers of stuff, then you get to have much more control of the program. I think there are some really important math fundamentals you need to understand computer science. I don't think you need to be have an incredible grasp of math to just start programming. I certainly did not. I was doing fine in school, but was not like strictly a math guy. For for all programming people need to, I think, kind of understand some fundamentals in like the algorithmic performance, which is like how complex your algorithm is. That's like a big determinant of like if your code will scale to very large IO, like very large data, if you're working in a job that deals with a huge volume of data, which is very, very likely. For game programming specifically, there's a couple of things that are pretty important. You have to like really have a solid grasp of the fundamentals of linear algebra. Yeah, all good, dude. It's like programming's hard. There's a lot of stuff that goes into it. It's very, very crazy discipline. Um, definitely the linear algebra is like a super fundamental of all the graphics programming, because this is basically this is what lets you efficiently draw stuff on the screen. Your screen is a bunch of pixels, right? And the computer wants to solve and all the pixels have like a different color to them. Your computer wants to try to solve for as many of those pixels colors in parallel as possible. And the way you accomplish that is by using transformation matrices. They're called in linear algebra. If you've ever seen, they're like they look like this, like so. And basically, this is like allows your math to come up with like funnel like a whole bunch of data into this kind of object, and then you get like an output that allows you to take your like initial coordinates of something. Let's say your like position in the game world, and then you can turn it into like screen coordinates. You can size it, rotate it, do all, and then from there you know all the colors and stuff. So that's like a huge. You do have to have some sort of knowledge of how that math works in order to really do like game graphics programming. For my game specifically, I've also had to learn a lot of like physics and the math behind. There's some like algorithms you have to understand for things behind like collision detection and stuff. This is not like incredibly complicated physics or math to do this. Where we have I have implemented like basically a whole bunch of, whenever you're doing any collision or physics detection, you've got like your entity has like a collider around it, which is a primitive like rectangle or circle or line or point. And basically, you just need to know and implement a couple of the algorithms that like tell you, okay, how can I tell if two circles are colliding? It's very simple. Actually, the simplest case is 2 points colliding. 2 points collide if they are the same point. There you go. Two circles collide if you think basically a circle is defined by a center point and then a radius, right? So you can tell if they're overlapping essentially if you add their radii together. If you add their radii together to a combined radius, this would be the distance from center point of one to center point of the other, where they would be not overlapping, right? Of if their combined radius, if the distance between the center points is the combined radius, they're not touching. As soon as your distance between those two center points is less than that, then you're within the combined radius, and then you're overlapping. So like that's the kind of stuff you would need to know. So there's obviously some geometry involved in that. You have to like kind of understand the geometry, the trig and stuff to do some figure out like projection type stuff, to figure out like your angles, rotations, and things. But this is like again like I would consider this to not be a crazy. This is like high school math and physics here to know to be able to figure out collision and gravity. If you on like the very high end, on like the edge of like if you are super in the weeds of like a programming discipline, or like any sort of software engineering discipline, you probably will need to have a much better grasp of some of the fundamental concepts, because physics and math basically are telling you our physical reality, right? They're defining what is the physical reality you're trying to engineer your problem to. And so if you don't have a grasp of like literally the problem of how like data is moving, or how your system is supposed to be interacting with the real world, you're just going to be fighting that the whole time, and your solution's not going to play nice with what are the real world limits of what things are going on. Yeah. Now hitboxing systems, it is a whole thing. There's like a ton of real time stuff you have to do to get hitboxing. I think Godot likely. Yeah, like I think Godot has a bunch of that stuff. If you're doing like a Diablo, Resident Evil style inventory though, you have to. I'm not sure if like it's as simple, because like you're kind of abstracting from the regular physics system to like that slot based collision. So there's a little bit more work. But I've got to sign off. It's time for me to go my day job. So I will see all you guys next time. I'm going to be out for the next couple weeks on vacation, but I'll be back in 3 weeks where we will continue on all of this. Thank you. See you guys all later.